this clip we'll look at double integration, and in particular we'll look at solving one of the questions from the first tutorial sheet on double integration, question 1b. The question is to evaluate the double integral of the function y e to the xy dx dy. So let's call this integral I, and if we remember that we are going to first evaluate the inner integral, and the limits we've got on this are from x equals 0 to x equals 1. Then we'll evaluate the outer integral from the limits y equals 0 to y equals 1. So the first thing we're going to do, as we say, is evaluate the inner integral. So let's let the inner integral be I1. So let I1 equal the integral from x equals 0 to 1 of y e to the xy dx. Okay, so we need to be integrating this integral with respect to x, so we're going to treat y as if it's a constant. So let's just think as an aside for a moment what we would do if y actually was a constant. So let's put that. So let's say we're looking at an integral I, let's just call it IC to distinguish it from what we've seen before, equal to the integral over the same limits, so x equals 0 to 1, of, let's say y is 4, so we're integrating 4e to the 4x dx. So when we integrate this, the 4 stays where it is, and then when we integrate e to the 4x, we get 1 over 4 e to the 4x. If you're not sure about that, then try differentiating it and see if you come back to the original. And again, that will then still have the limits on it. X equals 0 to 1 in this case. So we've seen that that's what happens, and then these two constants will cancel out with each other, and we'll just be left with e to the 4x between the two limits. Okay, so we've seen what's happened when we actually put a numerical value to y. Let's now go back and think about what happens in the general case when we've got I. So we've now got our I1, our inner integral, is going to be y times the integral of e to the xy, which is going to be 1 over y e to the xy, in the same way as we did when we had the 4. And we're still integrating between these limits of x equals 0 and x equals 1. So once again the y's will cancel out, and we get e to the xy between the two limits as before. So when we put the values in, we've got e to the y minus e to the 0, or in other words, e to the y minus 1. Okay, so that's the value of our inner integral. Now let's look at putting that back into the outer integral. So we're coming back to our integral I is now the integral from y equals 0 to 1 of our integral, which we called I1 dy. So that's the integral of e to the y minus 1 dy between the same limits, 0 to 1. So So we put those values in, we integrate. So we integrate e to the y, we get e to the y, integrate 1 in respect to y, and we get just y. So we get y equals 0 to 1, and then we can put the values in. We get e to the 1 minus 1 minus e to the 0 minus 0. And we can simplify that to e, or e to the 1, minus 2. And that's our answer for that particular double integral. So we notice at this stage now that we don't have any x's or y's in this final answer. It's just a number. All the x's and y's have disappeared as we've done each of the integrations.
Made with DoubleCast Pro.